This is Geometry, Unit 9 of the Semester 2 exam review. First of all, we're going to be trying to solve the length of our tangent. What we know is that we have a radius and we have the length from the center all the way out to our point on the exterior of the circle. So in this case, that would be the hypotenuse of our triangle. A tangent is always going to be perpendicular to the radius of a circle at the point of tangency. So we're going to set this up as hypotenuse squared equals leg squared plus leg squared. We know two sides of our right triangle. We're looking for the third side. So we have 80 squared. We have 48 squared. And the other leg, the perpendicular sides of the legs, is the x. So 8 times 8 is 64 with 2 additional zeros. 48 and 48 is 2304. So we'll take our 80 squared and subtract 2304. That gives us 496. And now we need to get the square out of there, so we have to take the square root of our 4096. And that gives us an x value. Now mathematically we would be plus or minus, but because this is geometry and a length, it's going to be a positive value. So the length of x, which is our tangent, is positive 64. When we look here, we have a circle. We have our vertex of each of these angles is at the center of our circle. So that makes all of these central angles. If a central angle is 64, then the arc is 64. You notice you have a big X and they go all the way through. These are diameters. So the 42 and the angle across from it, these would be considered vertical. So this is going to be 42 also, which makes the arc 42. We know that if you have a diameter, that your two angles are going to be supplementary. So that's got to be 138. And over here, the three angles have to add up to 180. We don't have vertical angles for this. It's clearly not 138. These two will be 138. That's one way you could do it, but this is 180. And we'll minus our 64. And minus our 42. That seems to be 74. 130, 170, 180 total. So that makes sense. So now I've solved, or I've calculated all the angles and all the arc values around our figure. Now we can go answer the questions. So PQ is going to be 42 degrees. ST is going to be 74. TPS, that implies it's 180 or more. TPS is everything but 74. So that's 180 minus 74, which is going to be 106. I'm sorry, that's not 180. That's 360. It's all the way around the circle, not counting. Okay, so we carry our numbers. We get 6. So that should be 286. RT is going to be the short direction around, because RT, 2 letters, implies that it's less than 180. So that's going to be these 2 values added together. Looks like 116. RQS means 180 or more, because it's 3 letters. RQS. Everything but 42. So 360 minus the 42, not including the 42. So that's going to be 318. QR implies that it's 2 letters, or 2 letters, which is less than 180. 138. PQS implies 180 or more. So that's 180 plus the 42. So that looks like 222. And TQR is everything but TR. We already figured out TR is 116. So it's 360, not counting our 116. So that looks like 244. Now, you don't want to just sit here and copy me. That's not going to do you any good. But you do want to start to see what some of the strategies are for setting this up, understanding that 2 letters is less than 180, 3 letters is 180 or more. Try to give you the narration about how to do these problems. Here we're trying to calculate what BC is going to equal. Now notice that we have 2 tick marks on these chords, so that's implying that these 2 values are going to be the same. The 2 arcs are going to be the same. So we have 360, not counting our 116. And then the remaining amount is divided by 2. So the measure of BC, arc BC, is 122. We're looking at ACB. We're trying to figure out this value. The 7s are relatively irrelevant. Relatively, I guess. So here, this is called an inscribed angle. The inscribed angle is equal to half the intercepted arc. So it's going to be half of 130. So that's going to be 65. So this is an inscribed angle because the vertex is on the side of the circle, where before we talked about a central angle is when the vertex is at the center of the circle, and that's going to be 130 degrees. But when you pull that vertex all the way back to the side of the circle, it really doesn't matter if you pull it back here or pull it back there. It would all be the same. It would come up and touch A, it would come up and touch B. That's going to be half of arc AB. Here we're supposed to find the measure of ST. And it also says we're finding the measure of SU. Well, that's not the right notation. That's diameter. So there should be 3 letters. They should really call that STU, which is half the circle, which is 180. So that's not really the correct notation. So understand that. So if this guy is 61, TU is going to be double 61. Just like we talked about over here, the inscribed angle is half the arc. That makes the arc double the angle. So 1, 2, 2. So if that's 122, this is going to be 100. This is going to be 58. So the measurement of arc ST is 58. And the measurement of arc STU is 180. That would be called a semicircle. Here we're looking for the measure of angle JLM. We're looking for this angle right there. Well, I know that this angle touches and opens up to this arc. So this angle is going to be half of that arc. If this is 88, this is going to be 92. Because together they got to add up to 180, which makes this arc 92. Because the central angle has a vertex at the center, those are equal to each other in terms of a degree. This is going to be 46. The measure of angle JLM equals 46 degrees. Angle KPL is going to be 92 because those are vertical to each other. Okay, we've seen this figure before also. This is not the correct notation. VST, not the correct notation for that. That's implying that 3 letters is 180 or more. This is less than 180, so it should only be VT. Measure of arc VT would be more appropriate for that. If this is 51, we know this side is going to be 102. This is 135. So to figure out our remaining amount, that's going to be 360 minus all of the other arcs that we know. So that's 360, not counting the 135 or the 102 or the 39. So that's 84. So the measure of arc VT equals 84 degrees. It's not an arc length. It's an arc in terms of an angle. VU. VU we figured out was 102. You couldn't figure out the 84 without the 102. Okay, what property do we have here? Here we have a quadrilateral in a circle. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. The opposite angles add up to 180 degrees. So these two would be considered opposite angles. So we know that 2y plus 104 is going to add up to 180. Minus over the 104, and I get 76. Divide by 2, and I get 38. So y is going to be 38 degrees. and then go in the other direction. 5x and 110 are going to add up to 180. They're opposite angles. Subtract 110, that gives us 70. Divide by the 5. 5 goes into 7 one time with 2 left. Goes into 24 times. So those wouldn't actually be considered a degree. Those would just be a value, but the total result is a degree. Okay, over here when you plug it in, 2 times y gives you a degree. 5 times x gives you a degree. Those are not degrees by themselves. All right, write an equation of a circle. So we have x minus h squared plus y minus k squared equals r squared. These are all statements that you want on your note card. This is the equation of a circle. Here was a theorem that's going to help you about circles. Here's a theorem that's going to help you about inscribed angles. So you want to have those. So our center is always h and k. So we're going to say x minus a negative 3. Notice I have to have those in parentheses. And y minus 0 squared equals the radius squared. So that gives us x plus 3 squared, gives us y squared, and 25. There's the equation of your circle. I plugged in my h and my k. I already knew my radius. So there's my equation. An equation is always going to have an x and a y involved. Here again, center is h and k. So you have x minus h quantity squared plus y minus negative 7 quantity squared equals 13 squared. That's going to give us x minus 4 squared plus y plus 7 squared equals 169. There's the equation of your circle. Your equation of the circle has to have an x and y. Now this one's a little bit different. What does number 9 not display? What does number 9 not have? We don't know what the radius is. The center is still considered our h and the k. The circle has a point on it at x comma y. So we're going to start with our equation up here. So that's going to be 6 minus the negative 1 and the y value, which is 12, minus 4. What we don't know is our radius. That's what we're trying to solve for. This is not an equation of the circle. We got to keep going. So this is 6 minus a negative, which means 6 plus. 6 plus 1. So this is 7 squared. This is 12 minus 4, which is 8 squared. So that's going to be 49 and 64. That's going to be your r squared. So that's 113. That's r squared. Well, you're right. To get the radius, you'd have to take the square root. But we're not interested in the radius. We're interested in the radius squared. That's the value in the equation, r squared. So we're ready to write our equation. So x, this becomes plus 1 squared and y minus 4 equals 113. There's your equation of the circle. Many of you on the quiz, you stopped over here where you had all the numbers. You want to get your x and the y in the equation. You want to know your h and the k. And you have to have calculated your radius squared. Jump back to number 6. What's the equation of the circle? You would have to look to see where the center of the circle is. The center of the circle is at 1, 2, 3 to the right and 1 up. 3 to the right and 1 up. So that's going to be x minus 3 squared plus y minus 1 squared. That is 3 to the right and 1 up. And our radius is 2. So that's 2 squared, which is 4. Got to square your radius. That's what the formula implies. Find the circumference of the circle. Well, you want to be sure that's on your note card. Circumference of the circle. 2 pi times 4.5. Well, the exact answer is going to be 9 pi. Because 2 times 4.5 is 9. If you wanted to know the decimal of that, 9 times pi, 28.27. That would be centimeters. That would be the distance all the way around the circle. Here's a question that's on your exam. A car has tires with a diameter of 27. How far would you travel if the tires rotated 1,000 times? So if that's our tire, and the diameter is 27, we need to know the distance all the way around the tire. So the circumference equals the diameter times pi. The circumference equals 27 pi. So that's one rotation is 27 pi. And you can do the decimal right now if you want. That would be approximately 27 pi. 8482. But we have to rotate that 1,000 times. We need 1,000 of these. So 8482 times 1,000. So that's going to move our decimal over 3 spots. And we get 84,823. Just about exactly. Those are inches. Next, we're going to be looking at the arc length of AB. Arc length of AB is right here. We want to know the length. We're not talking about the measure. A measure is a degree. A length is going to be in centimeters. So what you want to have on your note card is that the arc length over circumference equals the angle over 360. The amount of the arc proportionally to its circumference is the same as 150 is to 360. That's what they're trying to tell you. So we're trying to figure out this arc length. So we have AB, that's the arc of AB, over our circumference, which is diameter times pi. And you need the angle value that corresponds to the arc length. So that's 150 over 360. So we'll take our 34 times pi, and we're going to times that to the 150. And that gives us that big 16,000 number. And divide that by 360. So the arc length is going to be 44.5. These are centimeters. This one's a little bit different. They're telling you the arc length of right here is 81.64. We know that the angle right there is 260. We want to know the circumference and we want to know the radius. So we're going to use the same formula. The arc length, which is 81.64, over the circumference, which is what I don't know, is equal to the angle over 360. So I'll cross multiply, and that's going to give me 81.64 times 360, which is 29390.4, and that's going to equal 260C. Then we have to divide that 260C out of there. What's the weight part? Haven't gone anywhere. So those reduce and I divide. So that gives me 111 or 113.04. That is my circumference. So that gives me part of my answer. But if I want to know my radius, I need to use my circumference. Circumference equals 2 pi r. So that's 113.04 equals 2 pi r, and you need to get the r by itself. So we're going to divide by 2 pi. Now you need to be careful here. You've got to use parentheses. So we're going to take our 113 and divide it, use parentheses, by 2 times pi. But you've got to use parentheses in a lot of calculators. So that's just about 18. And that would be in inches. So if this arc was 181, then the radius would have to be 18. One thing I noticed from above, if you come back up here, this is ST is 84, but we were looking for VT, so that would be 84 and 39. VT is not 84. VT is going to be the combination of those two. So that looks like 123. The diameter of our circle. The diameter all the way across is 11. If you need to find the area of a circle is pi r squared. So we've got to use a diameter of 11 to determine the radius is 5.5. And that's what we're going to use for calculating the area of our circle. So pi times 5.5 squared. That's the area. 9503. And these would be centimeters squared. Area are square units. Find the area, or the area is 236 square inches. What is the radius? So you've got to use your formula, pi r squared, because you know this is a circle. And you're going to put 236. They don't have the pi symbol, so we just use 236 equals pi r squared. We want to know what the radius is, so we first got to divide by pi. So that's 236 divided by pi. Then we have r squared. How do you get rid of the 2 within r squared? Take the square root. And that gives us 8.66. That would be our radius. Here we're going to find the area of circle M. Well, we have a formula you would need on your note card. Sector area over circle area equals the angle over 360. The area of the sector compared to the area of the circle is the same proportion as the angle is to 360. So the first thing we've got to realize is that the angle they give us, 161, is not the shaded region. So that's 199. That's our angle. So our shaded region is 84 over the area of the circle. We'll just call it A. The angle is 199 over 360. 84, 14 times 360. That gives us this big 30,000 number. Cross multiply to the 199. So we're going to divide by 199, and that gives us an area of 152. And those would be meters squared. Square meters is the area of the circle. Let's jump down here with just a few moments left. Let's jump down here and handle these two. This is a square minus 16 circles. So the square is 32 times 32, which is 32 squared. Length times width is the area of the square. If that's 32 all the way across, then that's going to be 8 for every diameter, and each radius is going to be 4. The radius of each of these circles is 4. So we're going to minus 16 times pi r squared. And we can do that right into our calculator. 32 squared minus 16 times pi r squared. That gives us 219. Then the last question I want to be sure to go over, some of you had troubles with this on our quiz. We're looking for the perimeter around this shape. Several of you were not understanding that this curve was half of a circle. It's half of the circumference. So if this is a radius, the circumference is going to be 2 pi times 7. The circumference is 14 pi, but we want half of it. So 7 pi is the amount of the orange. What is each of these tick marks? How long is it from the top to the bottom? It's going to be the diameter of our circle. So our total is 63.99. That is your perimeter around the entire shape. Each one of these is 14 because the whole distance would be 14 there. But we don't add this amount. We only have the 3 on the outside.